works, right? Well, some people don't like to break stuff. Some people like to build stuff and make stuff, and build big things and dramatic, fast things, right? And there might be some of you that don't know there are more career options than just becoming a consultant or developing Java in some ERP backend application. So there's a lot of cool things you can do with a computer science degree, and you have to know programming, you have to know systems, you have to know Unix inside and out. So it's just to represent like the other side of the coin, because there's lots and lots of options for you if you have a CIS or CS major. So what is automation? It's pretty simple. Everyone does stuff over and over and over. Most of it is boring and useless and repetitive, right? So instead of doing it yourself, you build a robot to do it for you. And the bottom line is good engineers are lazy. We don't like being made to do stuff. If I have to do something more than 3 times, I'm going to write a script for it, and I'm going to put in revision control, and I'm going to make sure that it gets run whenever it needs to be run. So why should you care? I'm just a student. So what? This is what people want. This is what businesses want. Automation is a huge amount of value that you can add to yourself. What if I told you that I could do the work of 10 men, or 100 men, or 1,000 men, or women, or whoever? You know, that's what I can bring to a company. So that I pay for myself in 3 months, a month, who knows? But I only have 1 server. Yeah, you have 1 server today. Tomorrow you might need more. Tomorrow you might spin up a new VPS. You might decide that, hey, this WordPress site isn't performing so, let's throw another PHP engine in front of it, something like that. So if you can automate building these things, it's huge, it's fast, and it's very scalable. But this can't be automated. Bullshit. Anything can be automated. It doesn't matter what you think can't be automated, someone already has. And they might not be sharing because it was hard, but it can definitely be done. So don't let anyone tell you that something can't be automated. This very core business, anything can be automated. And will I automate away my job? Yes. Because whatever job you can automate away is shitty. It's boring and you don't want to do it. What your job should be is automating yourself. So what if you automate away all the problems, which is impossible by the way, and now you have to leave in a year? Fine. You go somewhere else, and now you say, well, I automated myself out of a job here, and they're like, when can you start? So let's get started. Some constraints for the presentation today, and there is a demo. We're talking Linux here. The same philosophy applies to Windows, but it's a whole different can of worms, a whole different tool set. The same principles are going to apply, but for now, we're just talking about Linux. So what do we need? We need revision control, we need configuration management, and we need a decently sized beard.
Where's your beard?
Some people might say, yeah, I don't have a beard, I can't grow a beard. Because I'm, I just never could, or I'm a woman. It's not the beard on the outside that counts, it's the beard on the inside, okay? So, the advanced topics we're not going to talk about too much today, but automatic provisioning of new machines. So you're going to use Cobbler in an open source world, or vSphere, which is VMware's offering. Build automation is where you take software, you build it into a package, and you deploy it onto a server automatically. We're not going to talk about that today. But you use Jenkins, Rundeck, and you're going to want a Yum repository or app repository to do that. And then release automation is the actual process of deploying software to a large number of servers, hundreds. And we're not going to talk about that. But, this is future stuff. Like, if you were interested and you got all your Puppet stuff like nailed down tight, and you're like, yeah, let's try something tough. These will make you cry. So, first piece is revision control. What does it do? Who knows what revision control who already knows what revision control is? I hope most of you do. But if you don't, the basic idea is you're editing files, oh, I broke something, how do I go back? What was it before? I don't know. You might have like a vim swap file, but you're kind of asked out if you can't get your files back. So revision control is just absolutely not negotiable. It's guaranteed to save your ass. And it's actually really easy to learn. Like if you learn Git, there's maybe 4 subcommands you need to know to get like a local repository going and get all of your config files into revision control. So like when you start editing your Apache config or whatever, when you break it, you can always roll back to a previous commit. So examples of version control, Git, definitely use this. Mercurial is also very good. I've never used it, can't vouch for it. Subversion, please don't use Subversion. It's terrible, branching is hard, merging is hard, just don't bother. And in the worst case scenario, you can just make a copy of your file with the data appended at the end. So configuration management, what does it do? We take a set of properties and configs, files, what have you, and we apply it to a node. And all of those rules and configs and all those manifests and shit, you store them in Git. And it generally requires a piece of client software on each and every node that you're configuring. Because something needs to apply the config, right? It doesn't just go. Now there are tools like Ansible that will like shell in and do it for you. So let's talk about those. Examples of config management. Puppet, very, very good. That's what I have prepared today. Chef is also good. They're basically fungible at this point. CF Engine, don't use this, just don't. And Ansible, it's very limited. If your beard is weak, you might want to start with this. So why config management? Repeatability. I stood up a server, it went down. I can stand it up in the exact same way. Visibility. I can look at a Puppet manifest and know exactly what that server is doing. Can you? Can you just like look at a server and just know everything it's doing? You can if you configured it using some kind of configuration methods. Consistency. All of my servers have the same NTP server. All of my servers have the same DNS and users and LDAP config and certificates and everything that an infrastructure needs to run correctly. And compliance. This might matter to you if you're interested in InfoSec and auditing and all those things. Is you need to be able to prove, yeah, all of my servers are protected against like that beast SSL attack. Why? Because you can see in the Nginx config that is applied to every server that this it's not vulnerable to beast because of the way that the chains are set up or whatever. So what can we do with config management? System level config, DNS, SSH, package management, kernel parameters, all the basics. And then you go to the application config, which is going to be Apache, MySQL, Nginx, PHP, whatever it is you're running on the server, apart from the base operating system. So let's move on to the demo. Now I'm going to tantalize you with a glimpse of what is to come. So here's a Puppet DB dashboard. You can see that we've got some data in here already. It's not terribly interesting yet, but we're just looking at our JVM heap. How many nodes do we have? How many resources? And so Puppet works in terms of resources, which means you have stuff like a machine's host name, their IP address, the type of operating system it's running. Is it Linux, Windows? Is it using Yum or Aptitude? So these are what we call resources. And over here we see we have Nagios core set up with a few hosts and services. And so we can see that we've got some hosts in here. Cool. And then if we go to the right IP here, being organized is important. That might redirect me and it's going to make me angry, but let's just... Yep, redirect. Okay, that's fine. One second. Just a little. So this is a ready-to-go WordPress site. So if we were to fill in our details, get our deets in there, we will have a working WordPress site. So this is all ready to go, and it's monitored in Nagios. So this is a great scenario to be in, right? We've already got Web Server 1 monitored. Ping OK. Packet loss very little. Close that. So what I'm going to do is I'm going to pare all this down, because all of these are running as VMs in my MacBook here. And what I'm going to do is I'm just going to roll back all of the snapshots. So basically I'm going to trash everything I did yesterday and today. And we're going to see if I can bring it back with Puppet. So let's revert. Let's specify the snapshot. All right, before Puppet, go to. You'll lose all the changes in the current state of your virtual machine. Fuck it, let's do it. Revert to snapshot. Yep. Remember, this is my database. This is all my hard-earned Nagios config. It's all going away. So who's familiar with WordPress, just in a nutshell? Okay, so can anybody just stand and tell me like 10 seconds of what WordPress is?
Content management with logging.
Okay,
features.
so what is it? Is it
CMS.
CMS, thank you. What does it require?
PHP.
PHP, MySQL. Perfect. What's that? LAMP stack. Not necessarily Apache, but yeah, basically. So I guess we're going to stand up a LAMP stack because we want some WordPress. Let's make sure that it actually works. Yep, all right, that's dead. Shit, it's all going down. Okay, I'm going to leave Puppet dashboard up just because bringing this back would be a nightmare. But we're going to bring back those other services. So here's my MySQL server.
Can you make it bigger?
Yeah, sure.
Did you make the requisite sacrifice to the demo gods?
I mean, no sacrifice to the demo gods.
So there's a problem.
Okay, so Joel at MySQL. Please grab MySQL. I'm not going to use speaker. Oh, where'd it go?
So you made the window bigger, but not the font.
Because I opened a new one.
Okay.
So big.
Crap, it's all gone. What am I gonna do?
It's right after the Joel.
Let's try this. Oh wait, actually. So we get a lot of debug. Oh, hey, there we go.
Oh, man.
Whoa, hey, we're installing stuff, class young.
Is
that Gentry?
Let's go over here. So on the right, we got the MySQL server doing a Puppet run. So it's going to apply all of the config that I've been working on so very hard. And on the left here, we have the Puppet master, which should also have some debug output going in just a second here. Now, to give you a quick walkthrough of what we ended up doing over there, I'm going to shell into the Puppet master here and on another emulator here. See that I've already got my key set up. Puppet just runs like any other daemon. So we've got Puppet config broken up into manifests and modules. So modules are a self-contained piece of Puppet code. You might make a module for MySQL. You might make a module for Apache, PHP, DNS. Whatever it is you want to set up, you can make a module for it. So let's take a look at the MySQL. So, who's comfortable with Ruby? Anybody? Nobody? I recommend learning Ruby. It's a very nice, very slow, but very, very easy to read and easy to write language. Oh, hey, there we go. Got some stuff going on here. So you can see here that we've specified a Yum repository. We're installing MySQL, package MySQL server, ensuring present. So if we go back to this, we can see that over here. You can see MySQL server, package name, config class, create resources, service MySQL D, ensure running, stop, what have you, what we want to call it. Enable, so like in check config, enable yes or no. So will it start on boot? Yes, of course. We require this MySQL server package, and so Puppet will generate a graph. Who knows what a graph is? Graph theory? Great, thank you. So Puppet will generate a graph of all the resources, and it will decide and pull in all the dependencies automatically. Now, Puppet is completely idempotent, which means that every time you run Puppet, it will achieve a certain given system state. It's not like a bash script. Like if I run a bash script to remove a directory, the first time it might succeed, the second time it will fail. Puppet is not like that. Puppet will ensure a consistent state every time you run it, which means you can run it all the time. Which means that as you change stuff, you can guarantee that you will have like a running sort of backlog of incremental changes you've made, and you can roll them back as well. Remember, we go back to revision control? So if we wanted to, we could roll that back and end up sort of where we start. Now, there are some side effects involved, but okay, looks like everything's working.
So going back on the snapshots was not rolling back Puppet, that was just...
No, we did not roll back Puppet because Puppet has all the source code in it. So if I rolled back that, I would have no source code. So let's show databases. Actually, let's go back here. So you can see, we're just defining classes and stuff here. Now, we want to actually define our servers. So we've got this funky looking thing. We've got MySQL.localDomain. So we're including Nagios as a target. We're including the base system, and we're including this MySQL server. You can see my root password, find address, default engine is InnoDB, and then we've got this WordPress database that we're ensuring. Now, again, if it was a shell script, and I'm running a shell script to create a database and a user and do grants, I can only run it once, right? Because if you try to do it again, it's going to fail. It's going to tell you the database already exists, the user already exists, and he already has those privileges. But Puppet is about ensuring a consistent state. So if I change this, it will run, update the password, and if I run it again, it won't touch it because it's done, because it can check, because it knows. This is powerful stuff. This is like 1,000 times better than a simple dumb bash script. So there it is. There's my WordPress table. So now we've got some stuff going. MySQL was running. That was just from one Puppet run. Good, great. Let's go back here. Let's shell back into Nagios here. Yeah.
Are your little boards what's like? Are your little board functions?
Ah, crap, it's not running yet. Let's leave that in the background and move on to our web server here.
Question, what is the test?
What's it? Where?
Do you dash test?
Oh, when I do dash dash test, all it's doing there is, when I do dash dash test, all it's doing is saying don't demonize, because Puppet will default to running as a daemon and run in the background and possibly mess with me while I'm doing the demo. So I'm running it as a one-off every time. But it actually doesn't matter. If this was a production system, yeah, I'd probably want it to just run, right? But I'm invoking it manually because we are doing a demo. Now there's a few pieces of magic here that I've sort of obfuscated for the purposes of the demo, but the Puppet Master and every Puppet client speak to each other using SSL certificates. So the Puppet Master is actually a certificate authority as well. See, I should have made a Puppet module for this, but I didn't. But it doesn't matter because it can't talk to Puppet. Puppet Master is overloaded here. Too much excitement. Now, PuppetDB over here, like I said, didn't touch it. There's two components here. There's the Puppet Master and PuppetDB. The Puppet Master is the sort of rule master. It contains all of the rules and manifests and stuff for configuring services, right? PuppetDB is a store of facts and resources. If you'll recall, resources are anything you can learn about a server. Every time a Puppet job runs, we store everything we can learn about the server, like what is the manufacturer, what's the MAC address, what's the IP address, anything else, any good facts that we can use to configure stuff later. So if I store like the IP address fact, or the operating system fact, or the package manager fact, I can use those in manifests to do any kind of logic I want. So if we go back to the code here, you can see that I set the bind address to the IP address. I don't even need to know what this node's IP address is. I just say, whatever your IP address is, use it. And if we go to the actual Nagios config here, you can see that everything Nagios is completely defined using the, this is a little bit more complicated. Basically, Nagios acts as a resource collector. So these funky brackets mean find every host you can, collect it, make a config for it, and then bounce Nagios if anything changes. So notify service means whenever something changes for this config, bounce it. Eventually doing a Puppet run. No idea why it's so slow. Okay.
Was there lots of new cows?
Yes. What's that? It's unexpectedly slow.
Right.
That's nice. There we go. So we are doing all kinds of shit here. We are adding the RPM Forge repo. We're adding EPEL because we're going to need some packages out of it. Looks like we're installing something. It's generally takes a little bit. Folks, unfortunately, this is a fairly complex environment here. There's a lot of interaction between Puppet nodes. And so this is a little problem. Of course, generally we don't go back and snapshot of the production system. But we can see here that at the very least it is working. And now this is a special case. Here we go. See? So right now I'm trying to drop in an apc.ini file. It's failing because that directory doesn't exist yet. So I would have had to install the package first, and this is where you will see that Puppet will do things in a random order. You can't necessarily always know what it will be unless you specify this is a dependency of that. So looks like MySQL Server is good at this point. Now Nagios is the consumer of facts from other services. It needs to know, hey, who's out there? Who should I be monitoring? And so as a consequence, when there's an issue with another server that hasn't checked in correctly yet, Nagios will have some issues. So we are installing packages here. Looks like the network is just really slow.
Are you in Wi-Fi?
Yeah.
Okay, that's not hard.
Yeah, so what it's supposed to be doing now is installing some packages.
Isn't there
We still have a few minutes.
Ethernet cable there?
So go back over here. I need a port.
Oh, you need a DOS.
You also can't upgrade your IP for
Oh.
16 gigs. 16 gigs.
What's the IP for the link server?
That's the one.
Yeah, it is.
What order are they? That's 1.4.
256.
Does he actually?
Yeah, I really need to know this space. Still not right.
No, no,
So yeah, we're just going through package by package. Are there any questions so far? You saw that we had the WordPress system up and running, so that includes PHP, APC settings, Nginx configuration, the reverse proxy configuration in Nginx, hosts. Everything was set up, ready to go. And
USB adapter.
generally, when you're working on a Puppet setup, what you're doing is write some Puppet code. You block out exactly what you think you're going to need. For example, over here in the Nagios setup, you say, okay, well, I need the service. It needs to be running. It has a status, has a restart, and require this package, obviously. The service requires a package, and we specify the package up here. So package Nagios ensure install. Might be other things that you want to set up, like Nginx. This one is nice and simple. So package ensure install. We've got a log rotate file I want to use, and service make sure that it is running.
Can you highlight it? Paul?
What's that?
It's hard to read the.
Oh, is it?
The red on the black is hard to read.
So you can see that it's a very declarative language. We're not specifying something like a bash script where you say first this, then that, then that, then that. The Puppet service can execute any of these in any order if they're not explicitly related, which is why I say require package Nginx. So if I say service Nginx enable true, this will fail unless a package is installed. I already know that. So I have to make sure that the package is installed and then required. So in this way, you can have a modestly imperative way of defining resources. But when it comes to something like a node definition, you can see that I'm just including bits and pieces as necessary. So include Nagios target, so monitor me, and then include the base system, which includes YUM settings, DNS settings, other bits and pieces that are just essential for everything to work. Now this piece is a little bit more interesting. So we've got this web server and then the regular expression. So what I'm doing here is I'm matching on any number. I have web server 1, as you may have noticed. But there are also web server 2 through several other. So let's see if that works. Probably not. But we're going to try anyway. So if we go back here, you can see that if the host name matches this regular expression, this will be applied. So we're going to include website, which has Nginx and PHP in it, and we're going to include the WordPress install, which actually pulls down the WordPress tar call, extracts it, and drops in the config file to talk to this database, MySQL.locally. So this is extraordinarily powerful. Remember what I was saying. For one server, not a big deal. When you have web server 1 through 200, this is huge because you just matched 100, 200, 300, 1,000 servers with 7 lines of code. So this is absolutely huge. And here's an actual production. Here's an actual production manifest. This is HopeLook's Puppet Master configuration. This matches on over 200 servers. And over here on...
Can I get bigger?
Yeah, sure, sorry. This also matches on over 200 servers. So that's 400 servers that have identical configuration. I've done it in 14 lines of code. It's just a slam dunk, super easy, super obvious, very, very obvious choice. Let's see, could not write. Probably because the package isn't installed. So we're still chugging along with packages. Now, in a real world scenario, you're not going to use EPEL, you're not going to use the CentOS repos, you're not going to use RPM Forge. You're going to have a local Yum repository. And so, as you'll recall in the presentation, we're talking about more advanced forms of build automation and other forms of automation. This will load. Go back to advanced topics here. Build automation. Let's say that my company actually makes a modified WordPress, and we need to do some unit tests, make sure the code coverage is good. We need to make sure that the quality is good. We need to make sure it performs correctly. We need to make sure that it just conforms to standards, right? We build a job in Jenkins to run all of these tests as a battery. Then we bundle that into an RPM or some other type of package. It doesn't really matter. And then we drop it on the server, we run our battery of tests against it, and then we say this is good for production. So this is more advanced stuff. So if you do have a Yum repository local to your environment, you can say, okay, we'll just throw it in the Yum repository. And any other dependency should be in that Yum repository. For example, right now HopeLook is in an interesting scenario where we can't update some servers. And the simple fact is that we pin to a repository that doesn't maintain those packages anymore. So to put it in a very diplomatic way, our environment is fucked. And that's just the way it is, because if you don't maintain your own package repository, you end up with scenarios like this. If we know we need PHP 5.3.30 and Remy stops building it for whatever reason, now he's on 5.4, we can't update anything. We can't do any security patches. We don't have any of that tooling in place. So what we need to have before Remy pulls the 5.3 packages is we need to have a build process in place where we just throw in the PHP source, it builds a package and throws it into our Yum repository. That way we have security patches, we stay on the version of PHP that we know works with our software, and just off we go. And we certainly don't have issues like this with Wi-Fi. So as you recall, not everything goes through in a Puppet run on the first time, because not everything happens in the order you expect. So like taken as a whole, yes, this will create a fully functional NICU system, but it may take a run or two, it may take 3, it may take 4. You don't have any way of knowing unless you've identified all the dependencies and put them in place beforehand. To my knowledge, this should do it. This this is an interesting scenario with Nagios. Who set up Nagios before? Anybody? Now, just so you know, Nagios is one of the pickiest, most difficult to configure services probably that's out there. And the pickiness comes from the complexity and power of it. You can do almost anything you can think of in Nagios. You can monitor anything you can think of. But it's extraordinarily picky because it's meant to be reliable. So Nagios' philosophy is fail early and fail fast. If something is wrong, it just dies. It means your config has to be perfect. Now, I can't generate perfect config 100% of the time, but Puppet can. So everything that you see here in the Nagios config folder, that's generated using Puppet. I didn't touch a single file, but it's all correct, it's syntactically perfect, and it's internally consistent. So if I go back to my poor Nagios server over here, oh, hey, there it is. No permission. Oh, I know it. Just a minor tweak. Very bad. Nobody do this.
Just project that for a second.
Bam. We got hosts. That was down 10 minutes ago. Now they're back. So,
You mean like 30, right?
30 what? Okay, so again, it takes a couple of runs. It doesn't do everything on the first try, but this is
Set use off to 0.
this is part of what we call promise theory. This dude wrote this whole paper on promise theory about the idea that when you have lots and lots of systems, you don't necessarily care what they're all doing right now, but you care what they'll be doing tomorrow, for example. So if I'm building some systems, maybe I don't necessarily care that they're not running Nagios yet. Maybe there's 50 new servers that aren't monitored, but they're not running any software, so I don't care. It's fine. But tomorrow I will, because tomorrow there is going to be a deployment. So the idea is this eventual consistency, that eventually all of your services are doing exactly what you think they do. Now if I ran this as a daemon, and I just went away, went to lunch and came back, it would all be done for me. That's an hour, 2 hours that I don't have to babysit a system, making sure packages install, making sure all the dependencies are resolved. So we've got our web server running now. Would you look at that? All packages are installed, Joel's cool blog. This didn't work, as you'll recall, just a few moments ago. Now, there's some issue with CSS, obviously, but I don't care.
Joe, hey,
Or doesn't matter. Loading up some tables, caching
Remember
the
the
opcode.
password because
Oh, password. Okay.
Oh.
Did I get this wrong?
I think your username
Use auth
was-
0.
Isn't it you?
No, the username was foo for the MySQL user, root user. Whatever, if it doesn't work, I'll just do it again.
Zach was right. You should have made the sacrifice to the gods.
So you can see that these are eventually checking in. Nagios is checking the services one by one, making sure that the ping is good. And this could be caused by any number of things. But we're back. WordPress is technically working. The best kind of equipment.
Yeah.
Just another WordPress site.
Oh yeah, it works.
Yeah, so it's actually doing stuff. It's extraordinarily slow because it's all running on one MacBook. But that's it. That's all I've got for you guys. Everything has now eventually come to a consistent point, which is the point where it was at the beginning of the presentation. How long did that take? 20 awkward minutes, maybe?
Faster than my hand.
Point is, it's faster by hand, it's more consistent than by hand, and you can do it over and over and over. Let's say that my super WordPress site has tons of people checking it out because I've got like the best cat pictures, right? I need more PHP front ends. Fine, do another one. Spin up another one. Spin as many as you want, because in 10 minutes they'll all be ready. That's the point of automation and configuration management. is you take what could have been like a whole weekend project. I set up this whole demo, including testing and all of the Puppet modules from scratch in about 4 hours. If I hadn't done it using Puppet, it probably would have taken forever. But I started last night. Now we have a working demo with a consistent, reusable, oh, there it is, with a consistent, reusable Puppet configuration. So, that's it. That's all I've got for you. I will publish the source code for this stuff and some manuals and such on GitHub. And if you guys want to take this for a spin, be my guest. If you have any questions, certainly now's the time. You can also ask me in the Swift IRC channel. Are there any questions now? Jolie's. Yes.
So, let's say that you've shown us a lot of different pieces of this puzzle, right?
Yeah.
You want to get started. What would you recommend starting with? Which, Nagios or Puppet? Which of those elements would you begin with and work out from?
Well, this is a very dramatic example. You're not generally going to have services reconfiguring themselves based on other hosts until you're a lot more comfortable with manifests and things like that. For example, this is one example, but let's go back to the idea where I have multiple PHP servers, right? Now, does everybody know what a load balancer is? Can you sort of guess what it might be? You put a load balancer in front of some other services behind it, and you make them act as one pool of resources, right? So let's say I had an HA proxy load balancer set up. Nagios can reconfigure itself to monitor hosts that get added to the network. HA proxy can do the same thing. So as I add a node, it can be added into the load balancer. As I retire it for maintenance or what have you, it can be pulled out automatically. I never touch HA proxy config, and I never touch Nagios config directly. I let the tool do all the work, and it's always going to be syntactically perfect, and it's always going to work. So there's a lot more you can do here. But if you really just wanted to get started with this sort of thing and just take it for a spin, I would say first get any configuration files you do have into revision control. Make sure they're revision controlled and put them somewhere else. So back up your stuff, absolutely. And Puppet, unfortunately, has its own DSL, which means that most of the languages you already know aren't going to apply to Puppet unless you know Ruby, which nobody did. So it is a bit of a learning curve, but just get to the mindset that anything can be automated, and you'll probably find a way to automate it. And unfortunately, Puppet does have its drawbacks. It requires a lot of really Puppet-specific knowledge to resolve some issues. Like as you can see, we had some pretty gnarly errors back here, and if I didn't know that this config worked, I might have said, holy crap, something is really broken, right? But I know that all I have to do is just keep running it until it returns this consistent state. So it's kind of like a, sort of a sixth sense to get a feel for what is going to work and what's not. So all you really need to do is just get some Puppet installed. Now I've got this in a client-server scenario where all the Puppet clients talk to one Puppet master that contains the code. You don't have to do that. If you have one server, one VPS, whatever you've got out there, you can just run Puppet locally and have it configure your one server repeatedly. Now, you've got the benefits of managing the config and revision controlling it, but you don't have the benefit of scaling. And so, that would be a good start, is install it on one server, get it all into Puppet, model all of your config as a Puppet DSL manifest or manifests, and then try it on another server and see if it works and see if it gets you to the point where you want. You start identifying bits and pieces that are missing from your manifest. So you're like, oh crap, I forgot my resolve.conf settings. Or I forgot these syscontrol settings that increase the IP before limits or whatever, right? You add bits and pieces, and as you go along, you end up building out this extremely big, fleshed out Puppet monstrosity that controls everything in the environment. And it's just incredibly useful and extraordinarily powerful when you want to keep just big environments under control. Yeah, like right now we have an ops team of me. I run the whole bitch. And the only way I can do that is using something like Puppet. So, just to give you an impression of what it can do. What? I don't know, it's still doing whatever it does. Yep.
You automate yourself out?
No.